Okay, well, welcome everybody to our special broadcast to celebrate NASA's International Observe the Moon Night. My name is Mike Murray. I'm the astronomer and manager of the Delta College Planetarium in Bay City, Michigan. And we're going to guide you through some of the coolest features of our nearest celestial neighbor. This event is also to celebrate the 12th year of operations for the Lunar Reconnaissance Orbiter, a NASA probe in low lunar orbit that has revolutionized our impression of the moon. So we'll be including a few views and even a little bit of video of some of the findings of the Lunar Reconnaissance Orbiter. Oftentimes, when we think of looking at the moon, even with a telescope, we think of thousands of craters. And while these are definitely cool to see up close, there is so much more to the moon than that. And so let's zoom in and take a closer look at some of the more interesting details on the lunar surface and what they've told us about the moon's history. To begin with, you know that the moon goes through phases, changes in illumination as it orbits around the Earth. We even have names for the primary phases of the moon. Waxing, we say, before the full moon because the illumination is growing, and waning after full moon as the illumination decreases. A full cycle of the phases takes 29.5 days, about a month. In fact, that's where the word month comes from. Think of it as month, in a way. Many ancient cultures, including some Native American peoples, based their calendar on the cycles of the moon. But for thousands of years, people have also known that the lunar calendar and the solar calendar don't line up perfectly. The lunar calendar completes itself about 11 days earlier a year, requiring an extra month to be added every so often. So, of course, we tell our time today using the solar reference, the solar calendar. Well, here are the phases you can expect to see right now this month, which is good because the growing or waxing phases before full moon means you can find the moon in the early evening right now. And there we are, October 16th. So this would be the phase of the moon if it's clear and you could go out and see it tonight. What is the best phase for seeing details on the moon? Well, it's definitely not this one. The full moon is when the sun is shining down onto the surface, from our point of view, directly down onto the moon. And so everything is awash in bright light. It is, however, the best time to see the splashes of bright colored material called rays. These result from younger impact craters that have sprayed lunar dust and rock for hundreds of miles across the surface. Now, when we say younger craters, we're still talking millions of years. The asteroid impacts that created Copernicus and Kepler, for example, were about 800 million years ago. But that's far younger than the moon's age itself, and when most lunar craters were made for that matter. Most of those impacts occurred between 3.1 and 4.5 billion years ago. Aristarchus and Proclus over here, for example, those are about half the age of Copernicus, about 450 million years. And then, of course, down here in the southern portion of the moon is Tycho crater. And look at how incredibly prominent those rays are. That's resulting from an impact only 108 million years ago. That's, believe it or not, recent history on the cosmic timescale. What's even more obvious to see during the full moon are called maria, the Latin word for seas. These are the dark lowland plains originally gouged out by huge asteroid impacts, which went then filled in with lava between 3.1 and 3.9 billion years ago. Our ancient observers before the time of telescopes thought they were seas of water because they couldn't really see the details very well. But we know today that they are actual leftovers of impact basins. But we still carry the naming convention started in 1651 by the Italian priest astronomer Giambattista. Oh, let me try that again. Giambattista Riccioli. Yeah, very Italian. Whose lunar naming system set the standard that we still follow today. Some of those names might sound familiar, and we'll get to those as we go into more detail on the lunar surface. But to get a truly spectacular tour of the moon, you need to look at any phase other than full, because that's when you can find the day-night line here called the terminator. This is where the shadows are longest, allowing you to see surface relief and depth. So let's take a tour that follows lunar features along the terminator as we go through the month. In terms of the phases, we often track its progression in days past new moon. Therefore, the young crescent moon would be referred to as 2 to 3 days old. The first quarter marks the 7 to 8 day old moon. The waxing gibbous is between 8 and 13 days, and full moon occurs right around 14 to 15 days. And so if you hear someone refer to the 15-day-old moon, of course they're not referring to it in geologic age. It's how many days past new moon. And that's a very common term. So you'll probably hear that, or you can even find that online if you're looking for certain phases, if you want to see pictures of the moon on certain days and certain ages. Well, then let's start with the very young moon. You know, the thin crescent in the west soon after sunset. This is also called the waxing crescent because its phase is growing larger each night. The first completely visible round maria, or sea, is in the northeast or upper right corner of the moon. This is known as Mare Crisium, the Sea of Crises. At over 450 miles in diameter, this basin was gouged out about 3.9 billion years ago. The moon here is between 3 and 4 days old and is a good time to see details at the western rim of the basin because of the longer shadows there. Because Crisium is set apart from the other lunar maria, it's often visible to the naked eye, even at full moon. Now this view is soon after full moon, when the moon is about 16 days old, and at this point you can see the details on the eastern rim of the basin. Look at how high some of those mountains are. They stretch almost 2 miles up from the base. And so it's really best to look when the terminator is nearby, because this is when you can actually see the height. You can get a sense of just how rugged the lunar surface is. Laser altimetry data, when they're bouncing laser beams off the surface from the Lunar Reconnaissance Orbiter, that was able to give us some elevation data. And the blue is not water. It's blue indicates below average height of the lunar surface, while yellows and reds are at above average height. The arrows there are showing just some hints of ridges there that are left over from ancient lava flows and have been almost completely covered by the basin floor. So having a satellite in orbit around the moon, there's a lot of instruments on that satellite, more than just a camera. Okay, before we move in time from the waxing crescent phase, there's another phenomenon we need to talk about. It's called earthshine. Have you ever noticed when the crescent is thin that it seems like the nighttime side of the moon is faintly illuminated? Almost looks a little bit grayish, like a grayish glow there on the nighttime side of the moon. Well, we call that glow earthshine because from the moon, the Earth would look nearly full, and all of that bright Earth light reflects off the night side of the moon and back toward our planet. As the phase of the moon grows, the phase of the Earth would shrink as seen from there and gives off less light diminishing the amount of Earthshine. So it's only when the moon is a thin crescent that you'll notice the Earthshine effect. Moving forward to the 6-day-old moon, 6 days past new, we see the crescent is widened to the point that other Maria are coming into view. You can see some of them here, and maybe a small one down here. Of course, the Sea of Crises is still there near the eastern limb, but now we have what's called the Sea of Fertility, a basin 520 miles wide, and the Sea of Nectar, much smaller at 210 miles across. What's interesting about this area is the large craters at the northwest of Nectar that are partly in shadow. See again what happens when you get some nice long shadows near the terminator? Some really beautiful depth and shape comes jumping out at you. The most notable over there is called Theophilus, named after the 4th century Coptic Pope Theophilus of Alexandria. At over 60 miles across, Theophilus is 2 miles deep, with a triple set of central peaks that rise over a mile from the crater floor. Of course, this is a telescope view, but it doesn't really take a really super large, expensive telescope to see some of the details because the moon is so bright to begin with. Now, you might also notice that Theophilus has a wide terraced inner surface with evidence of landfalls or some breaks in the material that fell off of the landslides that took place from the shelves. Now, we don't know the exact age of Theophilus. It's estimated it could be anywhere between 1.1 and 3.2 billion years ago, very old, like most of the craters, but it overlaps with this crater called Cyrillus. And because it overlaps, that tells us that it is younger. And you can also see how Cyrillus is a little bit worn down. This is a technique that scientists like to use in order to estimate the relative ages of craters. The U.S. Geological Survey has used data from observatories and lunar satellites and the Apollo missions to generate a detailed topographic map of the lunar surface. Here's an example of that same region with Theophilus and Cyrillus over here on the lower right. And these have become the basis of some very nice lunar atlases. And these maps can become very useful when you want to explore the geology of the moon. And more than just the names, you get a chance to see many of the different features. This one is actually one of my favorites. It's also been reprinted by Astronomy Magazine. But either way, you should be able to find a copy on Amazon or other book sites. But you don't have to necessarily go all the way into a deep atlas of the moon if you don't want to. There are some very nice guides you could probably find online, or even some fold-out maps that at least show you some of the more prominent features. Another fascinating lunar feature near the terminator of the 6-day-old moon is called Pasadonius, named after the Greek astronomer of the 1st century BCE. You see how it's up there in the northwest quadrant and also very large, but it doesn't look as deep. In fact, let's take a closer look here. It actually is about the same diameter as Theophilus, but it looks very different. Its floor was filled and uplifted by lava flows, which also explains the sinuous cracks in there called rills. Lunar rills are created when lava is active, creating lava tubes that later collapse to form these canyon-like features. A closer view with a larger telescope shows just how much the crater floor has been uplifted and the rills stretching all over the basin. It's pretty fascinating. Compare that with this view from the Lunar Reconnaissance Orbiter from an altitude of only 30 miles. Just one night later, on day 7 of the lunar month, Notice how much the lighting has changed. You can see a lot of difference in the terrain just from one night to the next. Theophilus and Pasadonius are almost completely lit now, and two more Maria have come into view. The impact basins. Most of the Sea of Serenity is visible in the northeast. This is one of the largest, clearly round, and most distinctive of the lunar seas, over 420 miles across. It, like the other Maria, formed probably between 3.8 3.9 billion years ago from a massive asteroid impact. And then, just to the south of Serenity, is the familiar name of the Sea of Tranquility. It was here that the first manned lunar landing took place in 1969. The equipment and foot tracks, all that stuff left behind by the astronauts, are way too small to see here from Earth, even with the largest observatories, but we can enjoy pinpointing the landing spot. Here's a view of the entire Tranquility impact basin, over 540 miles across. We're going to zoom into the lower left corner, the southwest section, right down over here. In fact, some people will tell you to use the term follow the L. You see these craters right here, how it makes kind of a capital L? If you were to follow that L and continue about the same distance between those two craters again, it's going to get you close. It won't pinpoint it precisely, but it's down in this area near the southwest corner that Apollo 11 landed. Let's zoom in a little more. There we go. See those two craters that were at the end of the L? And there are some small craters in that area. If you have a really clear view of the lunar surface at that time, there's not too much warbling from the Earth's atmosphere going on, you can actually identify some of those smaller craters and even pinpoint the spot. Now, fortunately, with a satellite like LRO, the Lunar Reconnaissance Orbiter, it's been able to see the evidence of the landing. You remember the lower portion of the lunar module served as a launching pad for the ascent stage, and so that was left behind, and that is clearly visible. And then there are also some of the experiments that were left behind. The lunar ranging retroreflector, which is used to measure the distance between the Earth and the Moon when we bounce laser beams off of it, the camera, the television camera that was left behind, and even some of the tracks. These are the foot tracks of Neil Armstrong when he took a short little traverse over here to Little West Crater. And speaking of those footprints, since the erosion is very, very slow on the Moon, for micrometeoroids, those foot tracks are going to last for at least 1 million years. On the next night of the lunar month, on day 8, the Moon is at or just a little past first quarter, which is when the Earth-facing side is half illuminated on the right side. Well, that is as seen from the northern hemisphere. If you were in the southern hemisphere, it would seem upside down. Well, to us. Well, this is an awesome time to study the Moon through binoculars or a telescope because a wide variety of features are now in view along the terminator. Can you see how rugged that is? The heavily cratered highlands in the southern hemisphere. You see how much brighter the terrain is there. And then there's a host of curving mountain ranges in the north, such as the lunar Apennines, the Caucasus Range, and the lunar Alps. One of my all-time favorite places to study are the lunar Apennine Mountains. This range stretches for nearly 400 miles, rising to over 16,000 feet in places. The variation of terrain, especially when they cast shadows, is really fascinating. Look up toward the northeast portion of the Apennines and you'll see a winding little canyon in here called Hadley Rill. It's going to look kind of small, but in fact, That is a very large, long canyon. This was the site of the Apollo 15 landing in 1971, probably one of the most scenic and scientifically rich locations of all of the Apollo missions. Apollo 15 was the first to bring along an electric buggy called the lunar rover, vastly extending the range of the astronaut excursions. Here is a view of Hadley Rill and one of their stops looking north. It's deeper than it looks. It's actually almost 1,000 feet deep in places. Like most other rills, this used to be a subterranean lava tube, which later collapsed to form a massive canyon, and it stretches over 50 miles. So what formed the Apennines and the other mountain ranges there? As the western side of the moon becomes illuminated, you can see that they curve around another giant impact basin called the Sea of Rains. Well, it was the impact itself that formed the basin, but also pushed up the mountains. Think of it as like the rim of a lunar crater. The mountains were actually pushed up by the asteroid impact rather than from plate tectonics like you'd see on the Earth. So the mountains are along the perimeter of the basin. Not far away from the Apollo 15 site, there at the northern Apennines, to the west is a gigantic crater that was filled in with lava called Archimedes. You can get a spectacular view of the rim there when the crater is at sunrise. See how long those shadows are? The mountainous looking rim there is 1.5 miles above the base. And that flat floor is the result of basaltic lava that filled the crater after the Imbrium Basin impact, the Sea of Rain, that formed that basin about 3.85 billion years ago. They can estimate a little bit closer what they think the age of the basin is because of the rocks brought back by the Apollo 15 astronauts. Well, in addition to Archimedes, what other nice craters are near the terminator on day 8? One of my favorites is right near the center of the moon, this large flat-floored crater called Ptolemaeus. In fact, Ptolemaeus is part of a distinctive triplet of large craters there. And here is a telescopic view. Ptolemaeus here actually measures almost 100 miles across. It's also been filled in with lava. In fact, it's filled in so deep you can't even see the central peak anymore. When Ken Mattingly was orbiting the moon in the command module of Apollo 16, he got this beautifully detailed view from lunar orbit, even with some of the tiny craters, but it still looks pretty flat. Before we leave this triplet of craters, we can use it as a guidepost to find a very unique lunar feature. You'll follow from Arzachel down at the bottom of the triplet, go down to the southwest. Kind of, at first, it looks almost like a gash or a crack in the surface. But it's really a huge long cliff known as Rupus Recta, or the Straight Wall is its popular name. The wall is a cliff 70 miles long and up to 900 feet high. In geologic terms, it's known as an escarpment, caused when a portion of the basin floor buckled due to pressures from below. Let's push forward a couple of nights to the 10-day-old moon. After first quarter, we call this a gibbous moon, Gibbous. It's a Latin word that means humpbacked. Well, think of it as a bulging half moon. It's an oval shape that takes a week to grow from half to full moon. This is about 3 days past first quarter right here. You've probably noticed some nice new prominent features that have popped up. The Sea of Rains is now visible in the northwest quadrant. It stretches over 700 miles across. And it was carved out by an asteroid, but they've estimated that the asteroid was probably about 150 miles wide. So you can imagine the violent collision and lava that resulted after that impact. Way down to the south is a new Maria that's appeared. It's called the Sea of Clouds, about 440 miles across. But when it comes to craters, this is one of the greatest impact craters on the moon, and it's easily visible in binoculars. It's called Copernicus, and it's more of a recent impact feature, probably only about 800 million years old, because you can still see some of the rays that are stretching out from the crater. Those ray structures extend about 500 miles across the surrounding Maria. At almost 60 miles wide, Copernicus is almost 2.5 miles deep. And like Theophilus, you can see some of the terraces up here and some of the landslides down near the bottom. And the central peaks are really spectacular. This crater did not fill in very much with lava afterwards. And this view from LRO shows the central peaks, which rise about 3/4 of a mile above the basin floor. This video here is a recreation using real data from the Lunar Reconnaissance Orbiter, allowing us to do an imaginary fly around or a flyby. This site is so fascinating that it was targeted as a potential landing site for Apollo 20, which unfortunately got canceled due to budget cuts. Some of the greatest lunar exploration was in the final 3 missions, and probably if we would have continued, we would have seen more and more spectacular sites like this up close. Well, now let's look to the south, because rivaling Copernicus as one of the most prominent lunar craters is Tycho, located in those southern highlands. Tycho is a very large and deep crater as well. Its ray system is one of the brightest features on the moon and extend for more than 1,600 miles. These light-colored streaks formed of material that ejected from the impact. And because it's only about 108 million years ago, a lot of that bright ejecta, as we call it, is still exceptionally bright, and you can see it for a long distance. 108 million years, remember, is very, very young for lunar impact features. Orbiting spacecraft like the LRO have given us some really beautiful oblique views of the crater and close-up views of the central peak, rising 6,500 feet above the crater floor. Isn't that something? South of Tycho, another favorite target, even for just small telescopes or binoculars, is this huge lava-filled crater called Clavius. At 144 miles across, it's one of the largest crater formations on the moon. It's also one of the oldest, at over 3.85 billion years old. Notice how many craters have impacted there after it formed, many of which have also eroded. But if there's no atmosphere or liquid water on the moon, how can you have erosion? Well, it comes from billions of years of micrometeorite impacts and widely ranging temperature extremes. Millions of impacts by tiny particles of pebbles and dust will erode away the sharp edges, while the day-night temperature extremes on the moon can range anywhere between plus 200 degrees in sunlight and minus 200 degrees in deep shadow in the lunar evening. So all those things combined for millions of years will age the craters, even though there's no atmosphere or running liquid water on the moon. Now, the other thing I really like about Clavius is, if any of you remember the Stanley Kubrick's movie 2001: A Space Odyssey, that was the site of the fictitious base Clavius base. Under excellent scene conditions, you can trace even farther south from Clavius to a crater called Mauritius. And if the tilt of the moon is just right, you can look way down near getting close to the South Pole. There's just a hint, an edge of a crater called Cabeus. Well, why would we want to care about looking there? Well, a lot of people were looking there in 2009 because there was a mission called LCROSS, which was looking to do an experiment to see if there was any frozen water in the permanently shadowed craters near the South Pole. And there was a large booster, an empty booster that went ahead of the spacecraft to impact in that dark, permanently shadowed area. And the LCROSS probe would then look for any evidence of water in the plume. And in fact, it did see the plume, and it did, in fact, find evidence of frozen water in the debris cloud. In fact, it estimated about 40 gallons worth of water in that debris. This is going to be the key to setting up a sustainable lunar base someday. So the South Pole is an area that's still under a lot of exploration. All right, so next we're showing the moon for tonight, October 16th, 2021. This would be the 12-day-old moon, just a few days shy of full. We have a few new features. Near the terminator, there are some more prime targets like the Bay of Rainbows up there in the northwest. Of course, this 160-mile wide bay holds no water, but more evidence of the basaltic lava flow that filled the Sea of Rain. West of massive Copernicus crater is Kepler, formed about the same time, and also has a pretty nice ray structure because of it. And then there's this interesting formation called gasendi crater, right on the edge of the Sea of Moisture. This is a good time to be looking because it bears a similar resemblance to Pasadonius crater that we saw earlier on day 6, you know, the one over there on the northeast quadrant. It has those cracks. It's about 65 miles across. It also filled with lava, and you can see multiple central peaks there that are still peaking above the surface. But it also experienced some uplift and lava channels. Can you see those? The rills, as we call them, used to be lava tubes that collapsed. So all of that makes for a really fascinating area to study. A lot of people who like to do photography of the moon through their telescopes will look for features like these. Oh, and then there's another thing. If you see this crater that kind of overlaps on the rim, some people will look at these two craters together and call it the diamond ring. So there's all kinds of interesting features there. Well, between day 14 and 15, we finally reach full moon. And as we noted at the beginning of the program, this is your time to enjoy all the maria, or seas, and the crater ray systems. So it's going to be pretty bright, but even in a telescope or in binoculars, you'll be able to pick out some of those features. This is also when people like to imagine the familiar features in the lunar seas, you know, like the man in the moon or the rabbit in the moon. And of course, there are many others. But you know what? This is also when I like to talk about something that happens during full moon. We sometimes refer to it as the moon illusion. You know, that feeling that the full moon is so big when it's rising. Well, the question is it really larger? It sure can feel like it sometimes. It can definitely look a little oval in shape right on the horizon, and that is due to refraction by our atmosphere. But does it really magnify the image? Well, some people have actually done some experiments and you can actually measure the apparent angular diameter. And guess what? The apparent diameter is exactly the same. So how can that be? Well, it was actually done by experiment back in the late 50s, as early as that. And it has to do with the way our brain interprets the shape of the sky. Even though the sky is a hemisphere, we perceive it to be a squashed down oval, almost like squashed down at the top. That causes our brain to compensate for how close it thinks the horizon should be, making the objects there seem larger. So, of course, that might be kind of hard to believe. You want to try this experiment then. Next time the moon is full and you see it rising and it does seem noticeably larger, turn around with your back to the full moon, then spread your legs, bend down, and look at the moon upside down from between your legs. I know, sounds kind of crazy. Don't let your neighbor see you do it, right? The illusion will seem to go away when you do that, and the moon will seem normal size. Why? Because you've eliminated the terrestrial frame of reference and the comparison to the shape of the sky. So again, it might seem kind of silly, but another way you can do that is if you take an aspirin tablet and hold it at arm's length, it's going to be right about the same angular diameter as the full moon. You can hold it to the moon on the horizon, wait a few hours and hold it up to it again later if you don't want to do the bending down looking between your legs thing. Well, after full moon, we say the moon is waning or getting smaller. And because the moon rises about 35 minutes later each night, these become the phases most often seen later at night and even in the morning hours. All of the features we just pointed out up to full moon will cross the terminator line again over the next 2 weeks. But this time the shadows will stretch the opposite direction. They'll stretch eastward instead of westward, showing off details in a whole new way. So it can be a great time to look at those features again, because you may see different details. And if you do watch those shadows, by the way, even if you just watch them for an hour or two, you'll see them change very gradually. The shadows may change length. Some of the features might come into view and change. Well, as we get ready to finish up here, I want to show you some video of the lunar surface from the eyepiece of a telescope. Can you see the warbly appearance? Kind of like looking through heat waves. This is perfectly natural, and you'll notice it too when you look at the moon through a telescope. It's caused by the turbulence of the Earth's atmosphere. This is also what causes the stars to twinkle in the night sky, because the moving cells of air is like looking out of the bottom of a swimming pool. So this is one of the things that can affect the details that you'll be seeing. If the atmosphere is clear but really, really turbulent, then you might not see quite as much detail. So whether it's by camera or binoculars or a telescope, or actually your naked eye, get out there and observe the moon. Yes, we know it can be kind of cloudy in Michigan. Actually, a lot of places might complain about clouds unless you live in Arizona. Then just wait for the next clear night and grab those binoculars or whatever you have and a nice little atlas and go and check out some of those features. It can be amazing. And because of how bright they are, they can be pretty easy. So here are some resources I wanted to leave you with. There are some nice maps and guides and activities. Like on the first one here, this is the site that NASA put out for International Observe the Moon Night tonight. They're still there, but there are a few other sites here as well that have some nice resources. Some of them contain activities, And if you'd like to know a little bit more about the Apollo lunar landings, I actually like this site because it has some nice descriptions and some nice photography. If you do have questions, please feel free to continue posting them to the chat window. And if you have some questions about these resources, we'll be happy to put them up there for you. But this will also be recorded in the video section of our Facebook site, and eventually it will go up on our YouTube channel as well. And here are the URLs for that, as well as our website, delta.edu/planet. There are some other resources that we put there as well on the astronomy page, including a lot of virtual resources that you can use if you're still doing a lot of things online. So I want to thank everybody for joining us tonight. Hope you enjoyed the program, and enjoy International Observe the Moon Night, and continue to go out there and observe. And hopefully we'll catch you for the next Facebook Live event, where we'll be taking a look at the James Webb Space Telescope, because after a long period of construction and testing, it's finally going to be launching, hopefully in December, as the successor to the Hubble Space Telescope. So again, thank you for joining us tonight, and we hope to see you again soon. Thank you all very much.